Now let us come to another type of grammar which is called as the LR parser. It is a non-recursive shift reduce bottom up parser. It is a widely used class of context grammar which make it most efficient syntax analyze technique. LR parser are also known as LR within bracket K parser, where L stands for left to right scanning from of the input stream. R stands for the construction of rightmost derivation in reverse, so we are using RM, and K denotes the number of look ahead symbols to make decision. So that means to say that if you have, let's just go back, suppose you have some production like this, ID plus ID plus ID, then it scans the string from left to right. So first ID, then plus, then ID, then plus, then ID. Then the solution is gone in the reverse. So you take E, then you go in the reverse format, that is rightmost derivation. That is the meaning of that. And the look ahead symbol is 1 or 2, or it may be any kind of look ahead symbol, that is K. So that is the meaning of that. So now, let us see. First of all, we'll come to the types of LR parser. There are three types. One is called as a simple LR or LR0 parser. We call as LR0 parser. The other one is the LR1 parser, or sometimes it's called as the canonical LR. And the last one is the look ahead LR parser. So let us go about with the first one, that is the SLR parser. We will just see a tree of it. There is the bottom up parsing is given in shift reduce, and shift reduce is the LR parser, which is divided into 3, that is SLR, LR and LA LR parser. So let us come to the first one, that is the SLR parser. Whatever the parser may be, it follows the following structure. It has an input buffer, it has a stack, it has an action and a go to, it has the parsing program, and it has the output. So whenever we have to do anything, first of all we have to create what is called as the parsing table. This is the parsing table at the last. The input is always whatever you input from the keyboard. The stack can be created automatically. The only thing is this one. So the parsing table consists of two actions. One is called as the action and one is called as the go to statement. So let us see each one of them first of all. Now before we come to the things which are necessary, we have to see what are the terms which are used. First of all, an item. First of all, an item. An item is, let's consider a production A derives X, Y, Z. Then this can be given as a production as A derives dot X, Y, Z, A derives X dot Y, Z, A derives X, Y dot Z, and A derives X, Y, Z dot. So you notice that the dot is shifting one step ahead every now and then. This dot shifts here, this from Y it shifts to Z, then Z it shifts to the last. This is what is called as an item. An augmented grammar is a grammar where we create a new line or a new line, you can say new line in the grammar at the top, so that becomes the starting symbol. So it is called as the augmented grammar. So if a grammar G is having a start symbol L, then augmented grammar is a new grammar G dash, in which S dash is a new starting symbol such that S dash derives S. The main purpose of this is to indicate the acceptance state of the input. Now we'll just come to this little later. We'll understand it more details of this. In this case, for example, if the grammar is A derives X, Y, Z, then the augmented grammar will come just one more line on the top. It will be A dash derives A. That will give you the augmented grammar. Now kernel items, it is a collection of all items in which dot are not at the leftmost end. So the items, if dot is not at the leftmost end, it is called as the kernel items. So in this case, these are the kernel items. And non-kernel items, it is a collection of all items in which the dots are at the leftmost end of the right hand side of the rule. So these are not, we'll understand this in a while. Now goto and closure, or the closure and goto, which are very important. They are two important functions to create the collection of canonical set of items. Now for creating these items, we also require a closure and a goto. Now what is a closure? Now in a context-free grammar G, if I is a set of items that the function closure can have construct using the following rules. So consider I is a set of canonical item, and initially every item I is added to the closure. If there is a rule, so you can see that if it is the first set of items, then every item is added to the closure. And the second says that if A derives alpha dot B beta is a rule in closure I, then there is another rule B such that B gamma, then closure of I becomes A derives A dot B beta and B derives gamma. This rule has to be applied until no more new items can be added to the closure. Now we'll understand this in a while again. Similarly is the goto statement. The goto statement is just to say that we are going to the next state by jumping one dot ahead. So if there's a production A derives alpha dot B beta, so you can see this dot will jump one step ahead. Then go to A derives alpha B beta, that means we are jumping above B. B is a non-terminal symbol. If you notice, it's very important that it's a non-terminal symbol. Then we say that go to this B will be A B dot beta. That means what? We are saying that this dot jumps one step ahead. So that is your go to operation. Now how do we construct the canonical set of items? So we require both the things. We require a closure and we require a goto. Now for each grammar, initially add the augmented grammar in C. Now for each item I1 in C and for each grammar symbol X, it can be a terminal or terminal, add closure I1 IIX. This process should be repeated by applying goto IIX for each X in II such that the goto IX is not empty and not in C. The set of items has to be constructed until no more set of items can be added. Now to understand this entire process, let's take an example. Now consider the grammar is this: E derives E plus T, E gives T, T derives T into F, T gives F, F gives bracket E, and F gives ID. So for this grammar, the augmented grammar becomes, we add one more line on the top of it, which is called as the augmented line. So E dash derives E and the rest remains the same. So this is called as an augmented grammar. So that gives a term which is we had talked about in the beginning. This is the augmented. If there is a starting symbol S, then S dash is added in the beginning. In this case we have seen that E, so E is the starting symbol, so E dash is added in the beginning. Now let's calculate the closure and the goto of each grammar. So let's see from the augmented grammar. The augmented grammar is this. So what does it say in the closure? It says that in the closure operation is a set of articles, and initially every item I is added to the closure of I. Initially every item is added. So initially means the starting. Every item is added to the closure. So we add all this, we add to this. This is one closure. These are the items, and all of them has been put dot in the beginning. You can notice everyone has been put dot in the beginning. Now the sooner we do that, then we have to jump, we have to see the first line now. Start with the first line. E dash derives E. This dot has to jump one step ahead. Now you notice E is a non-terminal. It is capital, so it's non-terminal. So we say it is a goto statement. That means to say, once we say it's a non-terminal, it is a goto statement. So we say goto I0, means goto from I0, E will give you the new set of canonical items, that is I1. So we see dot e. So we see dot e, there are two dot e's. This is dot e and this is dot e. So this dot will jump one step ahead, so it gives e dot, and this dot will jump one step ahead, that is e dot plus t. This is repeated again for the next line. E derives dot t. So there are two dot t's. So this will give you, go to I0 t, which is I2, which will give you e derives t dot and e derives t dot into f. Repeat this process for this line again. T derives f dot f. So you can see that it jumps one step ahead, so it becomes t derives f dot. And again you see f derives dot bracket e, so it jumps the bracket to one step ahead of the bracket, becomes dot e. So it jumps one step ahead, becomes dot e. Now you notice very importantly here. Now let us look at the grammar again. What does it say? If rule A derives alpha dot beta, b beta is a rule in closure I, and there is another rule for B such that B derives gamma. So if you notice that in the closure there is dot B, and in B there is a rule, there is some rule that is B derives gamma, then that also has to be added to it. So let's look at it. What does it mean here is, so you see dot E is there here. There is a rule for E. E derives E plus T, E derives T. So that also has to be added in the grammar. So you can see dot E, that means all the dot E's has to be added. So E derives E dot E plus T, E derives dot T. Again dot T is there, so all the T's has to be added. Again dot F is there, all the F has to be added. So that becomes I4. And F derives ID, it becomes F ID dot. So that is from I0 for ID, it gives you I5. So that is how it's done. Similarly, from I1, this dot has to go here. So dot means dot plus, that means E plus dot T it should go. So that means from I1 it will go to a new state. So I1 will go to a new state. This is I1 already. I1 will go to I6. So you have, this is I1, so E derives, so you can see this is dot is already over here, so no need to do anything. So you have E dot plus T, so E plus dot T, then this dot T is again there, repeat all the dot T's, again dot F is there, repeat all the dot F's. That gives you I6. Again if you see I2, the same thing is applicable in I2. T dot into F, so T into dot F it should come. So from I2, T dot into F will give you T into F dot F. Dot F is there, repeat all the F's. Again in I3 it's complete because the dot is in the last, there is no more production. I4, this dot E will come as E dot closing bracket. So I4 will go ahead. So you can see I4 from here it goes ahead to I8, which gives you this. So repeat the same thing. I6 gives you I9. So those are the things. I7 will give you I10 and I8 will give you I11. So these are the different steps. A complete diagrammatic representation of what we have done is given. I0 will go to I1, so you notice here is E is going. These are go to statements. So whenever you see it is a capital letter or a non-terminal, we say that it is a go to statement, and whenever we see that it is a plus symbol or a bracket or an asterisk, then we say it's a shift action. And whenever we see that there is a production, in that production there is ending like a dot, so E dot here, and you notice here T dot, this is a reduce action. ID dot, so you can see T dot, all these are reduce actions. So that is how we understand reduce. And there's an accept action when you get the starting symbol E dash or E dot, so that is an accept symbol. So finally, once we understand this, we can always construct the SLR parsing table. So if it is in this case, so this is how to construct. If it is a terminal, you see dot A is small, it's a terminal, then the action is a shift action. If it is a capital, it is a go to action. If it is ending at a dot, then it's a reduce action, but if it is a starting symbol, it is an accept action. So in that way we can always calculate it. And if it is a reduce action, then we have to calculate all the follow of A. Follow of A means follow of this. You see the grammar, if T derives T derives T into F, then we have to find a follow of T. If F derives bracket ID, then we have to find a follow of F, and so on. So that's the meaning of this. So let us see the final table. These are just a brief summary of what we have already done. This is the augmented grammar. In the augmented grammar we have label as 0, 1, 2, 3, 4, 5, 6, 7, 6 till here. We'll understand why, means this numbering is also important. We'll understand why now. Now we have the go to from I0, it goes to 1 over E. Now E is a capital letter, so it's a go to action. So we say 0 to 1, it is E. So 0 to 1, it is E. 0, 1, E. 0, 2, it is T. 0, 2, it is T. 0, F, it is 3. 0, F, it is 3. 0, opening bracket. So when you say opening bracket, it is a shift action. So you see 0 opening bracket, it is called as S4. Now what is the meaning of this S4? So this T derives F is obtained when we went from 0, that means we went from I0 with I0 with a bracket which is equal to I4. So if you look at, that means what? We can simply say that we are shifting to 4. So that is what is called as shift 4. So I0 4, that is a shift 4. Similarly I0 or 0 to D ID, it is 5. So it is a shift 5. 0 to ID is a shift 5, S5. So we can repeat in this way. So all the operations are given. So you can see 4 to E, it is 8. 4 to E, it is 8. It is a go to action. Now once the go to actions are, or the shift operations, these are all the shift operations are done, we have to see about the reduce operations. So we can see that, let's look at the reduce operations. That is R2, R2, R2 here. There's R4, 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 R4 here. There's R6, 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 R6 here. What does this mean exactly? Now let us understand this. Now let us look at 2, the state 2, that is I2 over, let's look at state I2 first of all. Now if you see state I2, it gives you E derives T dot. So you see that, as I told you, when the dot reaches the end, then that is a reduce operation. So E derives T dot. So E derives T dot is given in this one, E derives T. So just remember this number 2. So that means what we have to do is we have to find all the follow of E as per the rule again. The rule says that follow of A derives alpha dot, then find a follow of A. So here what we have is E derives T dot, so we find a follow of E. So I have already made a correction, plus bracket and a dollar. So what we have here is, this is the second one. So we can say R2 has to be kept in plus and closing bracket and a dollar. So in plus, a closing bracket in the dollar, we put R2. Similarly, you see in 3, state 3, let us look at I3. This is I3. T derives F dot. So T derives F dot is this one. T derives F dot is number 4. That means we find the follow of T, and the follow of T is given as plus, asterisk, closing bracket and dollar. So we have plus, asterisk, closing bracket and dollar. We say as R4. 4 means this number 4. R4, 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 R4. Repeat this process again for you see again in state 5. Let's look at state 5. F derives ID. So F derives ID is this one, which is 6. So and that means we have to find a follow of F. So the follow of F is plus asterisk closing bracket and dollar. So plus closing asterisk closing bracket and dollar we put as R6. So that is how it is done. So you can always calculate all the reduce actions, the shift actions, and the go to actions. So all this is done in the parsing table. Now once this parsing table is complete, then we can always pass any kind of input string. Now let's consider an example of how it is done. So this is the parsing table, and let's see as the example of how it is really done. Let me just explain to you this final part of the SLR parser, how it really works. So we have some steps which are given, 14 steps are there, and there's a stack, there's a symbol, these are the symbols which I use, and the input is there. This is the input ID into ID plus ID dollar, and what are the actions which has been produced. Initially in the stack we put as 0, and what we do is we take the input, and the input is ID. First of all we take the ID, and the remaining is asterisk ID plus ID dollar. So what we do is we compare 0 with ID. Now let's look at the table. 0 with ID is a shift of 5. 0 with ID is a shift of 5. It's only a shift. So when we say shift means we put 5 here. So 0 with ID, it is 5. So we put 5 in the stack. So ID is shifted. So it is shifted. That's the meaning of that. Again we compare 5 with asterisk. So look at the table. 5 with asterisk, it is a reduce of 6. Reduce 6 means F derives ID. So F derives ID. So you can see that F is the symbol which has been taken out. Now immediately what is happening is 5 is taken out of the stack. Now it exposes 0 with F. So let's consider 5 is taken out. So now you take out 5, only 0 is left. Now you compare 0 with F in the table. 0 with F gives you 3. So what we do is we write 3 in the stack. Again you take 3 with asterisk. Let's look at 3 with asterisk. 3 with asterisk gives you a reduce of 4. What is the reduce of 4? T derives F. So that means F has been changed to T. So you can notice that F has been changed to T. So F has been changed to T. Now if you take out 3 out from here, it exposes 0. So 0 with T gives you 2. So 2 is kept in the stack. Again you compare 2 with asterisk. Let's see 2 with asterisk, what does it give? 2 with asterisk gives you a shift of 7. So we can just simply write 7. So we are shifting. So asterisk will shift here, and 7 is written in the stack. Nothing to do in the stack. Again you compare 7 with ID. So let's look at 7 with ID. 7 with ID, it's a shift of 5. So we simply write 5 in the stack. So 5. So ID has been shifted. Again you compare 5 with plus. So let's look at 5 with plus. 5 with plus is a reduce of 6. So what is 6? F derives ID. That means ID is changed to F. So let's look at it. ID has been changed to F. Now once we change it, 5 is removed from here, it's exposing 7. So 7 with F is what? Let us look at 7 with F. 7 with F, it is 10. So 10 is kept in the stack. Again 10 with plus. What is 10 with plus? 10 with plus is reduce 3. Reduce 3. T derives T into F. So you notice very importantly here, T into F. Here also it's mentioned T derives T into F. How many symbols are there? 3. T into F. So what we have to do is we have to remove 3 things from the stack: 10, 7 and 2, exposing 0. So that means 10, 7 and 2 is removed, exposing 0. So 0 with t, we look at the table now. 0 with t gives you 2, so that gives you 2 here. 2 with t again, 2 with plus, look at this 2 with plus, it is a reduce of 2. Reduce of 2 is what? E derives t. That means t is changed to e. So let us look, t has been changed to e, and 2 is removed from here, exposing 0. So 0 with e will give you 1, so 1 is placed there. Again 1 with plus gives you shift 6, so just change it to 6, shift that, plus has shifted here. 6 with id, it's a shift again, you get 5, so it is a shift again. Again 5 with dollar, let's look at 5 with dollar. 5 with dollar is what? Reduce 6. Reduce 6 is id will change to f, so id is changed to f, exposing 6. 6 with f is what? 6 with f is 3, so it gives you 3. I think 6 with f is 9. Reducing 5, so 6 with f will give you 3. So there I have made a correction, so it gives you 3. Again the same thing, 3 with dollar, so 3 with dollar will give you r4. R4 is t will change to f, f will change to t, so you can see that it's changing to t, exposing 6. 6 with t will give you 9, so it gives you 9 here. Again 9 with dollar, look at 9 with dollar. 9 with dollar, it is a reduced 1, so it is e derives e plus t, so which is 3 symbols, so you remove 3 things from the stack, 1 2 3, exposing 0. So 0 with e, look at this, 0 with e gives you 1, so it is written as 1. So again you compare 1 with dollar, now look at that, 1 with a dollar, it is accepted. So that is why we have the acceptance here. So this is how the entire thing works for an SLR parser.